A collaborative filter cannot rank an item with zero interactions. LightFM folds its metadata into warp-trained embeddings so new items can enter the recommendation list. You'll see how to connect the pieces into a workflow that ranks new items from their details and compares them against click-only recommendations. I'm Professor Pi, teaching AI foundations with simple Python. Recommenders stumble when a new product shows up and nobody has clicked it yet. Teams still want that product to surface when it matches a user's taste. Hybrid cold start methods fill that gap by letting item metadata borrow signal from warm items. LightFM is a compact library that blends interactions and features, and warp loss trains for ranking behavior, which is what real systems care about. Top results, not perfect scores. At a more concrete level, we learn embeddings for users and for features. Items with no click history get represented by the features they carry. Tags, categories, whatever descriptive fields you have. Then, we score a new item for a user with the same .product ranking we use for warm items. The payoff is fast prototyping and straightforward interpretability. The downside is obvious when metadata is sparse or misleading. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now, we set up a tiny dataset to show the whole hybrid models fix and why we need item features next. This snippet creates a tiny catalog where two items have metadata but no clicks. Interaction-only recommenders have no behavioral evidence for sandals or mystery. So this is the exact cold start hole we want to expose. The clicks list is intentionally small and readable. U1 likes shoes, U2 likes a book, and U3 gives one extra shoe signal. The tags dictionary is the bridge we will give LightFM later, because cold items can still share features with warm items. The output confirms the setup by showing both cold items have zero training clicks. We need to turn those friendly IDs into model matrices so features can flow into embeddings. The next snippet does that. This example uses LightFM Dataset to turn friendly IDs into model-ready sparse matrices. The key choice is item identity features equals false, which makes item representations come from shared metadata features instead of one private ID per item. Data.fit learns the mappings. Build interactions creates the user item click matrix, and build item features creates rows of tags for each catalog item. That means sandals can reuse the learned shoe signal even without its own clicks. The output shows the model sees 3 users, 5 items, and 6 item metadata features. With matrices in hand, we can train the hybrid model. Training choices matter because we want ranking behavior, not numeric prediction. This code trains a LightFM model with loss equals warp and item metadata. Warp is useful here because the visible product behavior is ranking, not predicting a rating value. The model sees interactions, but each item score also flows through item features. So U1 can score sandals through the shared shoe feature. Data.mapping converts our readable IDs into LightFM internal IDs. And hybrid.predict scores only the cold candidates for U1. Increasing epochs gives the model more passes over the same tiny data, while lowering it makes the demo faster but less settled. The output shows which zero-click item the hybrid model ranks highest. To understand what metadata buys you, we build a plain baseline that ignores item features and treats each item as its own codependent object. This snippet builds the comparison model. Same LightFM class, same warp loss, but no item features. Plain data equals dataset keeps the default identity style item representation, so every item mostly stands alone. For warm items, that can work because clicks update their item-specific embeddings. For zero-click items, there is no metadata path from boots or novel into sandals or mystery, so the cold scores are not grounded in shared item meaning. We still call plain.predict on the same cold candidates to make the contrast concrete. The output shows the baseline's cold pick before we measure it formally. Now we want a compact, measurable check that the hybrid path actually helps cold items. The final snippet creates that evaluation. This snippet turns the cold start story into a small measurable result using LightFM precision at K. The test clicks are deliberately cold positives. U1 should get sandals, and U2 should get mystery, while those items had no training clicks. Passing train interactions tells the metric not to reward recommending items the user already clicked in training. The hybrid evaluation includes item features, while the plain baseline uses only plain interactions. With K equals 1, the question is strict. Did the right cold item reach the very top? The output reports hybrid cold, precision at K, and the lift over the interaction-only baseline. This toy mapping scales naturally to production. Replace the tiny tags with product categories, title engrams, or brand features, and run the same evaluation on a larger catalog and real user logs. The metrics and deployment checks stay the same. 3 short takeaways. The method: represent cold items by their metadata so they can be ranked alongside warm items. When to use it: anytime new items need visibility before they collect clicks and you have descriptive metadata to work with. One caveat: noisy or missing metadata can steer the model wrong. For a practical next step, run this pipeline on a larger public dataset like the Amazon product subset, and tune the LightFM no components embedding size and item alpha regularization while monitoring precision at K on intentionally cold items. If AI foundations in Python help, subscribe and watch the AI Foundations videos.